Staring down a list of 50 algorithms required for a technical interview feels like confronting a massive, disjointed wall of rote memorization. Viewing these algorithms as a single, logical continuum reveals the underlying architecture of computer science, connecting isolated code snippets into a coherent whole. The landscape breaks down into a structured framework of 12 distinct families. This ladder begins at the base with the simplest ways to sort data, and climbs step by step toward the peak of modern artificial intelligence. Mapping the territory this way gives every tool a specific home. When the relationship between tiers is clear, the learning process moves away from memorization and toward an understanding of how machine intelligence scales. The climb begins at the root of classical computing, with sorting algorithms, numbers 1 through 5. Their job is specific: put a list in order. Once data is ordered, we reach the next logical step. Searching algorithms 6 through 8 focus on a single mandate: find one element fast. Algorithms 9 through 12 introduce design strategies. These are the master methodologies, like dividing and conquering or taking greedy approaches, used to structure logic as problems grow in complexity. This diagram shows the graph category, algorithms 13 through 17. Their primary function is to navigate a network, finding the most efficient path between any 2 points. These classical tools form the bedrock of the discipline. A machine cannot learn from data until the system can efficiently organize and traverse that data. We cross the threshold from executing explicit human-written instructions into the era of machine learning, where algorithms begin to write their own rules based on patterns in the data. Algorithms 18 through 22 handle clustering and dimensionality. Their job is to look at a mess of raw information and find structure where no labels exist. Association rules 23 and 24 track behavioral patterns to determine what items are frequently grouped together in a transaction. This chart shows regression, algorithms 25 through 27. Here, the historical data points allow the system to predict a continuous numerical value. When the goal shifts from calculating a value to assigning items to a category, we use classification, algorithms 28 through 33. As the data splits into color-coded zones, the system predicts which class a new point belongs to. This tier transforms the computer's role from a calculator into a predictor, enabling a system to make educated guesses on data it has never seen before. From there, we escalate to the peak computational complexity of modern architecture: deep learning. Algorithms 34 through 36 cover optimization and neural networks. These focus on learning the weights, an iterative process of adjusting internal parameters to minimize error. This diagram illustrates deep learning models, numbers 37 through 40. By passing pulses through hidden layers, these systems identify patterns in images and maintain memory of sequential data. Algorithms 41 through 45 power natural language processing and recommendation engines. They are designed to parse the nuances of language and predict human preferences. This peak tier represents the edge of modern AI. It demonstrates how stacking the simple operations from the classical tiers allows a system to eventually process high-dimensional inputs like video and human speech. Finally, we reach the protective layer that wraps around the entire stack: cryptography and data handling, algorithms 46 through 50. In applications ranging from hashing to asymmetric encryption, their critical job is to protect and verify the integrity of the information. Taking a step back, the landscape is no longer a chaotic mountain. From organizing raw data, to generating predictions, to securing the final system, it is a single, comprehensible whole. The guide to mastering this progression is Imran Ahmed's book, 50 Algorithms Every Programmer Should Know. The practical application and Python code for all 50 of these algorithms are available right now on GitHub and neuralsca. The scale of the discipline is manageable when you have a map. Start at algorithm number 1, climb the progression, and subscribe to begin the journey.